Hello my dear grade 8 students. So today we are about to discuss the sixth lesson of your syllabus, science syllabus. This is regarding about the magnets. So on this lesson we are discussing about the properties of magnets and how they are going to behave. What are the things that have magnetic properties and those sort of stuff. So in the previous grades, in grade 6 and grade 7, we discussed about the things which has magnetic properties, and we discussed how magnets are going to behave, and we discussed that there are some certain materials which are attracted towards a magnet, and on grade 7 we discussed that there are two poles in a magnet called the north and south. So in this part we'll be discussing further things related to your magnets lesson. Okay, so let's see what are the areas that we are about to discuss on this part. So first of all, we are discussing about the magnetic poles. We'll be discussing about magnetic poles first. Magnetic poles, right? So there are several activities regarding the magnetic poles. So we'll be discussing first and foremost about the magnetic poles. The next one is about the magnetic field. About the magnetic field of a magnet. Magnetic field of a magnet. And next we'll be discussing, we'll be discussing about the compass. How to make different types of compass. What are the things contained in a compass, and what's the use of a compass? I think already you know these things, but still we'll be discussing further things related with the compass also, right? So the next one is called the geomagnetism. The next part that we are about to discuss is the geomagnetism. So that's the magnetic power or the magnetism or the magnetic field which contained on our earth. There's a certain magnetic power which contained on our earth also. This is called as the geomagnetism. The geomagnetism. And we'll be again discussing about the permanent magnets. So you know what are the things which are called as the permanent magnets. We divide several categories of permanent magnets. There were several types of permanent magnets as well, right? Like the bar magnet, U-shaped magnet, horseshoe magnet, and so on, right? So we'll be discussing about those permanent magnets in the final part. Then after that, we'll be doing the temporary magnets, or these things are also called as electromagnets. Okay, electromagnets. In an electromagnet, when the electricity is given, a magnetic field is getting generated. So we'll be discussing how to create an electromagnet, and what are the things which we needed, or what are the things which contained in an electromagnet. So these are the areas we'll be discussing on the magnets lesson. So we'll move on to the first chapter then to discuss about the magnetic poles. So to identify the things in magnetic poles, we'll be conducting a simple activity. So this is our activity. So here we'll be needing these types of materials. So first of all, you are given with a simple point here. There are several instances in the environment which we use the magnets. So there are several kinds of incidents in our day-to-day life which we use magnets. In a simple occasion is when you take a toy. In a toy we can observe magnets, and I think I think some of you may have these pencil cases. So in those pencil cases, to close the lid of the case, a magnet is being used. A magnet is being used to close the lid of the pencil case. We can close and open it by using the magnet. The magnet is the one which is used to close the lid, right? So that's one sort of an instance. So in toys and in pencil cases, I think you know this thing very well. If you go to your refrigerator, right? If you check your refrigerator at home, you can observe there is a layer of a magnet, right? And when you are closing the door of the refrigerator, the magnet is the one which helps to close the door, right? So there are several instances in our day-to-day life which we use magnets, right? So first of all, within this part, within this activity, we'll be discussing what are the magnetic poles of a magnet. What are the magnetic poles of a magnet? So my dear children, let's see how to conduct this activity. So first of all, you'll be needing these types of materials. First, you'll be needing these materials, right? So here, before discussing about the magnetic poles, first we'll see what sort of things which are having these magnetic properties. What sort of things which are having these magnetic properties, right? So here this activity mainly discussing about like what kind of things, what sort of things can be used with a magnet, or what kind of things which are attracted or which repelled, or else what kind of things that has a magnetic property. So here we are discussing things with magnetic properties. We'll be discussing first of all how to identify the things with magnetic properties. So to identify things with magnetic properties, you'll be needing different materials from your environment. Different types of materials are needed to conduct this experiment. So we'll be gathering these materials from your environment to conduct this activity. So what are the materials you need? So you need a bar magnet, then a thread, piece of thread, then you need a stand, a coin. So coin, then I'll take the slide somewhat upward so that you can see. So this is the iron nail. We need an iron nail in the next part. Iron nail. You need an iron nail, right? Iron nail is really important. If you don't have an iron nail, then you can find out a like a nut, or else a nut and bolt. That's also okay, right? Or else a piece of iron, right? Like a string. That is also okay, right? So this nail, this is called as the brass nail. Brass. It is made up with brass. Brass nail. You'll be needing a brass nail, right? This is made with brass. Okay, right. So if you don't have a brass nail, you can find out a piece of copper. Conducting wires, the ones which used to conduct electricity in our houses, right? So you can take a piece of conducting wire which have been removed from the from your house, right? You can take the wire of it or the string of it. You can use that string for this process as well if you don't have a brass nail, right? So the next one, this is here a piece of rock, or else you can take a stone. Piece of rock or else a stone, right? So the final one is the plastic rule. Plastic ruler, right? You can use any plastic material for this purpose, right? You don't need a ruler, right? You don't need a ruler for this thing, but you can use any kind of a plastic material. So these are the materials which we collected from our environment to observe what are the things which are getting interacted with a magnet, right? So here we are going to discuss what are the things which are getting interacted with a magnet, right? So we'll be needing these things. Okay, now let's see how to conduct the activity, right? So the method, how to conduct the activity. Now first of all, you need to hang the magnet by using the stand. By using the stand, you need to hang the magnet, right? So that's the main thing which you have to do first, okay? So we'll hang the magnet first by using the stand, right? So I'll draw and show. So this is the stand. Now first of all, we need to hang this magnet, right? So this is the thread. And this is the bar magnet. The bar magnet. And this one is the stand. This is the stand. Right. Now, first of all, we need to hang the bar magnet by using the thread on the stand. So, we'll write the steps. Hang the bar magnet on the stand using a thread. So first of all, we need to hang the bar magnet like this. Okay. Then the next one. So here we are finding out how to, or what are the things which are getting interacted with the magnet now. So the next thing is, after hanging this magnet, we need to bring those materials near the magnet, one each at a time. Okay, one each at a time. We need to bring those materials, right? So that's how the experiment is being conducted, right? So the next step, bring the materials near the magnet, one at a time, and observe the changes. So we need to bring one material at a time near the bar magnet. Then we need to observe what kind of a change is going to occur within the magnet and the material that we bought, right? So this is how the experiment is going to be conducted. So we'll move on to the lab to observe what will happen in each of these instances, right, my dear children? So now let's see what are these magnetic materials and what are the non-magnetic materials. So in this activity, we are going to find out what are the things which are getting attracted towards a magnet, or else what are the magnetic materials, what kind of things which shows the magnetic properties. And the other thing is the other type of material is what kind of a material or what sort of a material which do not attract to a magnet. So these materials are referred as non-magnetic materials. So now we are going to identify what are magnetic materials and what are non-magnetic materials. So I have several materials in here. I have a stone, an iron nail, a plastic ruler, then some coins, and a brass nail, right? So these are the materials that I have. So I have some coins, a stone, an iron nail, a brass nail, and a plastic ruler. So these are the materials that I have. Now what I'm going to do is, I have a magnet which hung on a stand in here. So this is my magnet. So now what I'm going to do is, I'm going to take one of these materials. I'm going to take one of these materials towards the magnet and see whether that material is going to attract towards the magnet or not. So let's conduct the activity and see whether the materials are getting attracted towards the magnet or not. So I have this coin. Now I'm going to take this coin near the magnet and we'll see whether it is getting attracted towards the magnet or not. So let's see. So you can see that the coin is getting attracted to the magnet and it's keeping steady without falling to the ground. So this coin is a magnetic material. Coin is a magnetic material. So I'm going to remove it. I keep it in this near to the magnet. I'll keep it in here. So these are the materials which are getting attracted to the magnet. Then I'll use the other coin. This is a 1 rupee coin. The earlier one was a 10 rupee coin. So this is a 1 rupee coin, smaller 1 rupee coin. Then I'm going to take this one near the magnet. We'll see. So the 1 rupee coin also attract towards the magnet, right? So the coins are getting attracted towards the magnet. So we can say that the coins are magnetic materials, right? Then, so coin goes to here, magnetic materials. Then I'm going to take the stone. So this is the stone. Now I'm going to take the stone near the magnet and we'll see whether it is getting attracted or not. So you can see that it's not getting attracted to the magnet. It's not getting attracted to the magnet. So stone is not a material that has magnetic properties. We can't attract a stone towards a magnet. So stone, I'll keep it in here. Then I'm going to take this iron nail. So you can see the iron nail. So we'll see whether the iron nail has magnetic properties or not. So you can see here the iron nail is getting attracted towards the magnet. So it's keeping steady without falling to the ground because the magnet attracts the iron nail. So iron nail has magnetic properties, right? So I'm going to keep the iron nail in here as it shows magnetic properties. Now I have a brass nail. So this is an alloy. Alloy means it's made up with two types of materials. It's a metal but made up of two types of materials. Now in brass we use zinc and copper, and together zinc and copper, right? When you mix together zinc and copper, we can create the material, or we can create the metal called brass. So this is a iron nail. This is an iron nail which is made up of brass. So we'll see whether the brass is going to show magnetic properties or not. So you can see that the brass nail is not getting attracted towards the magnet, even though it is a type of a metal. See, even though it is a type of a metal, but it is not getting attracted towards the magnet. I'll take the iron nail and I'll show the difference between the brass nail and the iron nail. So this is the iron nail. So iron nail is steadily getting attracted towards the magnet. So there is no trouble in identifying as the iron nail as a magnetic material. So now see this one, the brass nail. So even though brass nail is getting contacted with the magnet, there is no attraction. See, there is no attraction. If I am going to release my hand, see, you can see that the brass nail is going to fall down. Means that brass is not a material which show magnetic properties. Brass is not a material which show magnetic properties. So even though it is a metal, it's not a magnetic material. So I can remove it to here, as it is do not showing any magnetic properties. Now the final one, the plastic ruler. So I'll take the plastic ruler and bring it near the magnet. So like in the stone and in the brass nail also, the ruler is also not getting attracted to the magnet. So we can say that the ruler is also, or the plastic ruler is also a type of a non-magnetic material. So I'll keep it in here. So my dear children, we can see that there are some materials which show magnetic properties. These are those types of materials, some coins and an iron nail. And there are some materials which do not show magnetic properties. So these are the materials which show magnetic properties, means that these materials are getting attracted towards the magnet, iron nail and the coin, right? And these are the materials which do not show magnetic properties: a stone, a brass nail and a plastic ruler, right? So these are the types of magnetic and non-magnetic materials. So we'll find out even more things which show the magnetic and non-magnetic materials when we are discussing the further things related to the lesson. Right. So you have observed what has happened in each of the instances when you bring near each material towards the magnet, right? When you bring each material near the magnet, you observe the results of the experiment. So we'll see what has happened in that instances. So I have given you a table. So we'll see how to fill out this table according to our observations. So what are the materials which are given? We had a coin, iron nail, then brass nail, then after that we had a stone, and we had a plastic ruler. We had a coin, iron nail, a brass nail, a stone and a plastic ruler. These are the materials which we are given with. So after conducting the activity, we observed whether these materials are getting attracted to the magnet or not. So let's see what has happened. So the coin, you could observe that the coin has got attracted towards the magnet, attracted to the magnet. Coin was attracted to the magnet. Then the next one, iron nail. Iron nail also attracted to the magnet. Iron nail also attracted to the magnet. Then the next one, brass nail. So you observe that brass nail was not attracted to the magnet. Stone also not attracted to the magnet. Stone also not attracted to the magnet. Then finally the plastic ruler. Plastic ruler was also not attracted to the magnet. So these are our observations from the activity. So you can observe there are certain materials which are getting attracted towards the magnet, and there are some certain materials which are not getting attracted towards the magnet. Okay. So this is also been referred as, if it is not getting attracted to the magnet, right? If it is not getting attracted to the magnet, these materials are known as non-magnetic materials. Non-magnetic materials means that they do not show any magnetic properties. That's why they are not getting attracted towards the magnet. So what are the examples? Brass nail, stone, plastic ruler, wood, cloth, those kinds of materials, they do not show any magnetic properties. Those things are not getting attracted to a magnet. So the things which are getting attracted, like the coin, the iron nail, these things are called as magnetic materials. Magnetic materials. Non-magnetic materials, magnetic materials. The things which are getting attracted to the magnet are called as magnetic materials, and the things which do not getting attracted to the magnet are called as non-magnetic materials, right? So the final conclusion that we can come across from the experiment is, there are some certain materials which are getting attracted to the magnet, and there are some certain materials which are not getting attracted to the magnet. That's the final conclusion that we can come up with the experiment. So we can write, I'll take the slide somewhat up. So our final conclusion is, there are some certain materials which getting attracted to the magnet. These are referred as the magnetic materials. And there are some certain materials which are not getting attracted to the magnet. These are referred as non-magnetic materials. So we'll write our final conclusion. There are materials that attracts with a magnet. So you know that these things are called as magnetic materials. Magnetic materials have magnetic properties. That's why they are getting attracted to the magnet. So these are called as magnetic materials. Magnetic materials. So these are called as magnetic materials. Why does magnetic materials getting attracted to a magnet? It's because that they have magnetic properties. They have magnetic properties. That's why they are getting attracted towards a magnet. So magnetic materials have magnetic properties. Magnetic properties. Magnetic materials are having magnetic properties. That's why they are getting attracted towards a magnet. So we'll move on to the next one to discuss about what are the things which are referred as non-magnetic materials. So non-magnetic materials are the materials that do not show magnetic properties. The materials which do not show magnetic properties. So first we can write there are materials that do not attract with a magnet. That do not attract with a magnet, right? So these materials are known as non-magnetic materials. These are called non-magnetic materials. Non-magnetic materials. These are called as non-magnetic materials which are not getting attracted to a magnet. Then specialty in non-magnetic materials is we know that magnetic materials which are getting attracted towards a magnet has magnetic properties. So non-magnetic materials, they do not have magnetic properties, right? Non-magnetic materials do not have magnetic properties. Non-magnetic materials do not have magnetic properties, right? So these are the observations which we can take from this experiment, right? And finally, we have concluded there are magnetic materials and there are non-magnetic materials, right? So we'll move on with the next thing. So once again, you are given it, what are the things which called magnetic materials. So in here, the materials which are attracted to the magnet are called as magnetic materials. So the things which are attracted to a magnet are called as magnetic materials. So magnetic materials, they have magnetic properties. So to produce more powerful magnets, we use alloy called ferrite. So we use magnetic materials to prepare or to produce magnets, right? When preparing or when producing magnets, we use magnetic materials, right? So to produce magnets, magnetic materials are really important, right? So there is an alloy. Most of the times we use iron to produce magnets, iron or steel, right? But there are some certain instances, right, which we use more powerful magnets. So to produce that powerful magnets, we use an alloy called ferrite. But what do you mean by an alloy? See, what is this alloy called? What is an alloy? Alloy means it's made up with, it's a type of a metal. Actually, we can't say it as a metal, right? It's because that it's an alloy. It's made up with mixing several metals, or else we can use or we can build up an alloy by mixing a metal with a non-metal as well. We can mix a metal with a non-metal to produce alloy, or else we can mix two or more metals together to make an alloy. So alloy is a mixture of metals or else non-metals. So I can provide you several examples for an alloy. If you take brass, you can remember we took a brass nail in the earlier experiment. So brass is made up with adding copper with zinc. So copper is a special type of metal and zinc is also a special type of a metal. By joining these together, right, we use or we build the alloy called brass, right? By adding copper and zinc together, we create the alloy called brass. And there are some certain instances we can create an alloy by adding a metal with a non-metal. So steel, which used to make knives and railway tracks, engine parts, it's a very hard substance. It's even harder than the iron, right? Steel is a material or metal, right? Actually, it is not a metal, it is an alloy. So steel is an alloy which is made up with the addition of iron with carbon, right? By adding iron and carbon, we make the alloy called steel. Steel is very hard. Steel is very hard than the iron. That's why we use steel to make knives and engine parts and railway tracks. Okay, steel is very hard. It's very hard than the iron. It's an alloy. So these are the stuff which is called as alloy. So there is an alloy called ferrite. What is that? Ferrite. There is an alloy which is called as the ferrite. Ferrite is made by adding or by mixing oxygen with iron. We refer that thing as iron oxide. Iron oxide. So iron oxide is resulting ferrite alloy. Okay, iron oxide, when oxygen is going to mix with iron, ferrite is getting created mainly, right? So that's how the ferrite is getting created. This ferrite or oxides of iron can be used to build up more powerful magnets. Those can be used to build up more powerful magnets, right? Ferrite. So ferrite is the material which we use to create more powerful magnets, right? So here, magnets made with steel. I told you that most of the times we use steel to create magnets. But to create more powerful magnets, we use the thing called or the alloy called ferrite. Steel also an alloy, right? Steel also an alloy, but it is made up with adding carbon with iron, right? Here ferrite means addition of oxygen with iron is resulting ferrite. So ferrite is used to create more powerful magnets. So these are magnets which are made by ferrite. Okay, magnets which are made by ferrite. So here you are given with another point. See, magnetism, you are given with another point. See, magnetism or the magnetic property. Magnetism or the magnetic property is a special property which can observed in some materials. So in some materials we can observe these what? Magnetic properties. So if a material has a magnetic property, then definitely those things will be attracted towards a magnet, right? So these things are also referred as magnetic materials. The things which has a magnetic property are also called as magnetic materials, right? So let's see what are the other things contained in our lesson, right? So here now we studied about what are the magnetic materials and what kind of things which we use to create a magnet. Now we are going to discuss what are the poles of a magnet, how to identify the poles of a magnet, what are the features that can be observed in a poles of a magnet, right? In a pole of a magnet. So we'll conduct this activity to observe or to see what are the things which can be observed, or what are the things, what are the properties that we can observe in a magnetic pole. So first of all, we'll identify what are magnetic poles. So you'll be needing these materials to identify or to study the magnetism around a magnet, right? Or to identify the magnetic poles. So you'll be needing these materials. First of all, you will be needing a bar magnet. You'll be needing a bar magnet. Bar magnet. And you will be needing iron powder. You'll be needing iron powder, right? Iron powder. right? This is also called as iron fillings, right? Iron fillings or iron powder. Next one, a polythene paper. Polythene paper. Then finally you need a piece of paper or else a cardboard. Finally, you need a piece of paper. So these are the materials which you'll be needing to identify the magnetic poles and the magnetism around a magnet, right? So what are the things? You need a bar magnet, iron powder, polythene paper, a piece of paper. A piece of white paper would be more accurate. You can take an A4 sheet for this activity, right? So we'll see what is our method to conduct the activity. So method is really simple. What you have to do here is, first of all, you need to take that magnet and we need to wrap that polythene paper or that polythene sheet on the magnet very well. It's because that if you keep iron powder, right, if you keep iron powder near a magnet, iron powder will get attracted towards the magnet and it will be difficult to remove this iron powder from the magnet. So that's why we are using that polythene paper, right? So first of all, what you have to do, wrap the polythene paper or polythene sheet around the magnet. Right? Wrap the polythene sheet around the magnet. Next step, we have to take that A4 sheet or else the paper sheet and we need to spread iron powder or iron fillings very well all around the A4 sheet. Okay. So in the next step, take the paper and spread iron powder very well. So we need to take the paper, that A4 sheet, and we need to spread iron powder very well. So I told you that we can use a white color paper. Most often thing is an A4 sheet. Okay, right. So take the paper and spread iron powder very well. Then in the third step, we need to place the magnet which wrapped with polythene paper or the polythene sheet on top of the paper, and we need to tap gently on the paper so that the iron powder will get attracted towards the magnet. So the third step, place the magnet on the paper and tap gently place the magnet on the paper and tap gently, right? So this is our final step. So we need to place it like this, magnet and we need to tap on the paper so that the magnet can attract this iron powder very well. Right. So we'll head on to the lab and we'll conduct the activity, and after that we'll write down our observations and conclusions. Right, my dear children. So now we are going to investigate whether the magnetic power or the magnetism in a magnet evenly spreads or not. Means that we are going to identify the poles of a magnet. So let's see, if you take a magnet like this, now this is called as a bar magnet. This is called as a bar magnet, this one. So you can observe there are two terminals. This terminal or this end, it has a red color, and this end it has a blue color, and here the blue end is marked with capital S and the red end is marked with capital N. Means that these are the two poles. These are the two poles of a magnet, right? The two poles of a magnet, right? The north pole and the south pole, the two poles of a magnet. So what are the magnetic poles, or what kind of things are the ones which are called as these poles? So magnetic poles are the things which has the most magnetic power. So here we are going to investigate that a magnet has more strength on their poles. So here I'm going to take another bar magnet like this. So you can observe that this bar magnet, I have covered it by using a polythene cover. See, it's because that now I'm going to drop some iron fillings into it. I'm going to drop some iron fillings into it so that to identify the more powerful area in the magnet. So the thing is that if I'm going to use a naked magnet like this, and when I'm going to drop some iron fillings, right? So it would be hard to remove those iron fillings from this magnet once again. So that's why I have covered this thing by using a polythene cover so that I can remove the iron fillings very well. Iron fillings or iron powder can be removed very easily if I'm going to cover this thing by using a polythene wrap. So now what I'm going to do is I'm going to take some iron powder. This is called iron powder or iron fillings. So I'm going to use these iron fillings and I'm going to spread on this A4 sheet like this, right? Need to spread it. So I'll use a glass light to spread this thing here and there. So I'm gonna spread this thing like this on the surface of the paper. On the surface of the paper, I have spread the iron fillings or the iron powder. Right. Now what I'm going to do is, I'm going to take my magnet. I'm going to take my magnet and place it on this like this, and I'm going to tap gently like this so that the powder would attract to the magnet, right? Okay. Now you can clearly see that more amount of powder, iron powder, is attracted towards the end. See, if I'm going to take this one to far like this, so observe at the two ends we can observe large number of iron powder. See, at the two ends we can observe more amount of iron powder. It's because that at the two ends of a bar magnet we can observe the most or the highest magnetic power. So these ends or these areas which has the highest magnetic power in any kind of a magnet are called as magnetic poles. So in a bar magnet we can observe the magnetic poles at the two ends of it. These two ends are the ones which are referred as, or these two poles are the ones which are referred as the North Pole and the South Pole. More often we use the red color to indicate the North Pole and South Pole being indicated by blue color. So in this activity it's obvious to us that in a bar magnet, the magnetic poles are located at the two ends or at the terminals of the magnet. And also at the poles, we can observe the highest magnetic power or the highest magnetism. Now I told you that it's not easy to remove this iron powder. So see, it's not easy to remove iron powder. Even though it is covered with a polythene wrap, it's really hard to remove this iron powder. No matter how much I'm going to try, I can't remove all of these things. 100% of iron powder cannot be removed from this magnet because it is really difficult to remove these things. So that's why it's not good to use a naked magnet like this, right? So if you use a naked magnet like this, then it would be hard to remove these magnets, and it would be hard to remove these iron fillings, and you have to remove this magnet. You can't use it. So that's why we are covering this magnet by using a polythene cover, so that we can easily remove these iron fillings from the magnet. When I'm going to remove this polythene strap, I can remove the iron fillings quite easily. So this is all about with the magnetic poles then. So remember, in a bar magnet, when you take a bar magnet, the magnetic poles are located at the two terminals, and the most magnetic power could be observed at the two terminals in a bar magnet. So our observation was quite simple. So this is our observation then. You have observed the iron fillings or the iron powder like this, right? This is how the iron powder or the iron fillings are going to arrange around the bar magnet. This is the way of arrangement. You have observed this thing. So why does this thing is going to occur? So first of all, we'll write down our observation. So iron powder or iron fillings, iron powder attracted right. So iron powder attracted to the magnet. Iron powder attracted to the magnet according to the figure below. According to the figure below. So we could observe more iron powder, right? We could observe more iron powder at the either side of the bar magnet. At the either side of the bar magnet, we could observe more amount of iron powder. So the next step we can write more iron powder was observed at the two ends. Two ends. So we could observe more iron powder at the two ends, right? Like this. So what is our conclusion from this activity? What is this? What is the experiment of this activity? What is the conclusion of this experiment? Right? So what is the conclusion of this experiment? Why does the iron powder getting attracted to the magnet like this way? Why does the iron powder, more iron powder attracted to the ends of the magnet or to the either side of the magnet? It's because that magnetic power, when you take the magnetism or the magnetic power, the highest amount of magnetic power, or we refer that thing as the magnetic power, is getting concentrated. Concentrated means most of the magnetic power, where we could observe the most of the magnetic power. So the magnetic power is getting concentrated, or it is getting magnetic power is getting more effective, right? We can observe more magnetic power at the two ends of a bar magnet, at the two ends of the bar magnet. So magnetic power is getting concentrated, or more magnetism, more magnetic power can be observed at the two ends of the bar magnet, right? At the two ends of the bar magnet, we can observe the most magnetic power or the most magnetism, right? So we can write as the conclusion, that's why more iron powder is getting attracted towards the at the two ends. That's why more iron powder is getting attracted at the two ends. It's because that two ends has the most magnetic power, right? So our conclusion in this thing then, magnetic power, or the power of a magnet we'll write this thing as power of a bar magnet. That's more accurate, no? Because we took a bar magnet in this experiment, no? So we'll use the bar magnet. So power of a bar magnet is concentrated. Concentrated means getting more, large amount. So large amount can be referred as concentrated. So power of a bar magnet is concentrated power of a bar magnet is concentrated at the two ends at the two ends. So at the two ends, we can observe the most magnetic power or the most magnetic field, right? So my next point is most magnetic power is observed at the two ends in a bar magnet. In a bar magnet. So the most of the magnetic field, most magnetic power, the most magnetism is observed at the two ends of the bar magnet, right? So these areas which has the most magnetism or the magnetic power is called as the poles of a bar magnet or else a poles of a magnet. But here we specially took a bar magnet. So therefore, these two ends which has the most magnetism or the most magnetic power are called as the poles of the bar magnet. Poles. So poles means those are the areas which has the most magnetic power, right? So we can write at the final point. Final point is area where most magnetic power is observed, area where most magnetic power is observed, called magnetic. I'll write down by using a different color. Magnetic poles. Magnetic poles. So area where most magnetic power is observed called magnetic poles. These areas are called as, or these areas are called as magnetic poles, right? So magnetic poles. So in a bar magnet, we can identify the magnetic poles at the two ends. Okay, at the two ends, we can observe the magnetic poles, right? So we'll move on. Regions of a magnet or area of a magnet where magnetic power is concentrated, or else we can observe more magnetic power, are called magnetic poles. Are called magnetic poles. These things are called as magnetic poles. So there are two such poles. We can observe two such poles in a magnet. So I think already you know these two poles. So we'll write it. What are those two poles? These two poles are called as, first one, north pole, and the other pole is south pole. North pole and the other one is the south pole. So these are the magnetic poles in a magnet. So magnetic poles are the area or the regions which has the most magnetic power or the most magnetism. Magnetic poles, right? So these are the things which are referred as the magnetic poles then. Good, right? So here sometimes magnetic poles can be identified in a magnet like this. There are different shapes of magnets, you know. This thing is the one which is called as the bar magnet, and this is called as the horseshoe magnet, right? Like a horseshoe. It's like a horseshoe, no? So it's referred as the horseshoe magnet, right? So it's not the U magnet. U magnet is like this, in the shape of a U, like this. This is the U magnet, right? This is the U magnet, and horseshoe magnet is not like that. Horseshoe magnet, the two ends of the horseshoe magnet is somewhat closer than the U-shaped magnet. This is the horseshoe magnet. This is the U-shaped magnet. So you are given with a horseshoe magnet. You can observe the two ends are somewhat closer rather than the U-shaped magnet. So there are some magnets which are colored by using red and blue colors, and on those magnets we can observe these poles. Those are being printed like this. So here you can observe the North Pole. See here, North Pole, that's why the N letter is being represented. And here you could observe the South Pole of the bar magnet. So we use blue and red colors, right, to color up the two poles. So you can observe the red color with North Pole and the blue color with South Pole. Then in the horseshoe magnet also you can observe the North and the South poles. So the most magnetic power or the magnetism in a horseshoe magnet can be observed at the two ends like this. At the two ends like this, right? The magnetic poles. But there are some certain situations, right? Magnets are being produced, or there are some magnets, especially these things can be observed in certain instruments. In different types of instruments, we can observe these magnets. On those magnets, the poles are not being represented, or poles we can't observe like these colors. These colors cannot be observed, and the poles are not marked on a magnet. There are some certain magnets where the poles are being not marked, right? So here, these magnets, if you take these magnets, here the poles have been marked, and here this is just a magnet without the poles. There are poles, but poles have been marked, haven't been marked. So this thing is magnet with unknown poles. Magnet with unknown poles means that we don't know what are the poles. We don't know the areas which has the most magnetic power. Those areas are not printed on the magnet, right? Not being shown in the magnet like these cases. So these are magnets with known poles. Here you can clearly observe that north and the south pole is being marked. So here those things are not being marked. So this magnet, we don't know the poles. So here a magnet that has unknown poles. We don't know the poles. In this case, these two magnets, we can observe the poles clearly because those two poles are being printed on the, right, or being marked on the magnet. Right, my dear children? So these are the magnetic poles. So there are some certain instances, there is a magnet, or there are some kind of magnets which do not have known poles, right? So in the next chapter, we'll discuss how to identify the poles of an unknown magnet like this. How to identify the poles in an unknown magnet.